This is going to be tough to do without the smartboard, so you'll have to pay close attention. On your first slide, so we're doing something called relations and functions, which means we're going to be working with graphs. Yeah, really awesome. You can work with a lot of cool data, which is why you can do a lot of cool things with relations and functions. Because it means we can put the phone away. Put the phones away, guys. Which means you can do a lot of cool things where I can just send you guys off, you can collect your own data, and then come back and actually work with your own data and see if you can figure out some trends. And actually do some analysis on stuff you like. So I use this stuff because I like hockey, so I do hockey stats with this kind of stuff. Other people can go and do actual surveys and make a living off this kind of stuff. So this can be fun. This is a graph. If my smartboard worked, I would draw on it. Doesn't work. So I'll try it from my computer. What you guys are going to see on these graphs is lines. Lines like this. And they're going to be all over the place. What you need to know is a few things. You need to know quadrants. So that'll be the first thing you want to fill in. Starting in the top right corner, we call that quadrant 1. You'll see it as quadrant I because they use Roman numerals all the time. And then you go counterclockwise. So this top left corner becomes quadrant 2. The bottom left becomes quadrant 3. And the bottom right becomes quadrant 4. That's one of those more or less trivial things that you need to know just so we're always on the same page when we're talking about things. Another thing you're going to need to know is some definitions, basic definitions. You're going to need to know what a domain is. Anybody know what a domain is? What is Josh?
Sections.
Close. It's a domain on GoDaddy commercials. That's like that's a web address. So GoDaddy actually what they do is they sell web addresses. Yeah, you would never know it by their commercials, but that's what they do. Domain in math is the values of x that something can be. So if something is in between 1 and 3, that would be its domain. If the x values are never larger than 3 and never less than 1. So if I asked for the domain of this room's age, we would take the youngest person's age and the oldest person's age, and that would be our domain if that was our x values. Do it. Who's the youngest person in here? 14? Ella, how old are you? 14. I'm probably the oldest. I'm 24. So if we put that, if we put that along the x slide, our domain would be 14 to 24. So x would be, the way you'd actually write it out, we're going to put it over to the side. Because 14 would be our smallest number, it goes first. You go less than or equal to x. So that says x is always greater than or equal to 14, because everyone in here is older than or the same age as 14. And then you go less than or equal to the oldest person. So if you were to read that right now, it would say everyone in this room is either older or the same age as 14, or younger or the same age as 24. Nope, so imagine you're reading just chunks. So just read this chunk right here. That says the ages in this room are greater than, right? Because remember these, is it the Allegheny? Yeah. Worst Allegheny in the world. So the ages in this room are greater than or equal to 14. And then if you read it as a second chunk, the ages in this room are less than or equal to 14 or 24. Yeah, Josh.
And then after you have to do afterwards you have to do everything real.
Yeah, that's something else we'll get into in a bit. Next thing, what's range? If domain is your x values, what's range? Y. Your y values. Oh, killed that, Dawson. A simple way to remember that. A simple way to remember that is just go alphabetical order. So domain is X and range is Y. Alphabetical order. So, if we wanted to graph our age compared to our height, what do you think is the height of the smallest person in this room? Is anybody taller than 5 or shorter than 5'5"?
Probably.
Yeah? Anyone shorter than 5'4"? Anyone shorter than 5'3"? Anyone shorter than 5'2"? 5'1"?
No.
So 5'1" is our shortest height? Okay.
5'1.5".
So if we just call that 5.1, and who's the tallest person in this room? Anyone over 6'1"? Is anyone 6'1"? There we go. So you do the same thing, guys. The smaller value starts here. Yeah, if we spike Boris's hair, he wins. The heels. You put the smaller one first, and you follow the same steps. Less than equal to, less than equal to, and you put the bigger one up here. Carter 6'1". And in the middle, because we're doing range, it's a Y. Easy, right? Cool. Thanks. That was smooth too, eh? Like I meant to. Next thing is these are really two quick things. Intercepts. Yeah. So there's two intercepts. There's the y-intercept and the x-intercept. What's more important is you're going to need to know which one of these is x and y. So the vertical one is your y-axis, and your horizontal is your x-axis. So you'll have a y-intercept and an x-intercept, and it's where it crosses those lines. Thanks. Really hard on. It's also where the value is equal to 0. So you flip it around. If you understand that, stick with that. If you want another way to think about it, that can be a little bit confusing. When y equals 0, that gives you your x-axis. When x equals 0, that gives you your y-axis, your y-intercept. Make sense? All right. Functions. This whole unit deals with relations and functions. All functions are relations. So every single relation that we work with is also a function. Does that make sense? It's not a metaphor. But a function is a special type of relation. So a function is one where for every individual x value, there's an individual y value. So you'll never have, if we took this line right here and looked at it, for every value of x, there's only ever one y. So it's a function. But a relation can have two values for each x. So if we did a big loop and it kind of curved on itself, yeah, one value of x could have multiple values of y. So think about it in this room. If we labeled out height and age, like we've talked about, is every person here who's 14 going to have a different height? Are you sure? So nobody... Not always. What about 15? So is every person in here who's 15 have a different height? No, that's not true. I'm willing to bet that that's not true. That there's going to be people in here who are 15 and have the same height. Right? So that would be a relation, but not a function, because they share things. So put your hand up right now if you're 15. Put your hand up. Keep your hand up right now if you're 5'6". 5'6". Oh yeah. Hands up if you're 15 and 5'6". So if we were to graph it, we got 3 people right there who would all be under your x value. Right. Yeah. Which isn't good.
Start yelling.
I like that one. I want that to be like my last.
I know the US players make that rule like I would never be in class.
Go for a minute. You guys all good with those definitions? Any questions? Okay. Flip it over. I'll do A for you guys. So in this top right corner, it's a little tougher to see on your paper, probably. But there's a whole bunch of, you don't have to flip the paper over. No, just the second slide. Second slide. It's kind of tough to see. But up here you can see a little better, so use this if you need to. What it wants you to do is find all the points, A, B, C, D, and O. And it wants you to label the coordinates for those points. When you label coordinates, again, you go alphabetical order. So you put the X coordinate first, and then the Y coordinate second. So for A, if you looked at A, you would see that the X value of it is 1, 2. So you put 2, comma, and then the Y value of it is you just count up. So 1, 2, 3, 4. That would be your answer. Every time you label a point, X, then Y. That easy. Go ahead, fly through it. Do the next, fill out the rest. Do B, do C, do D, do E. What's up, Emily? You good? Oh, I think I had a question. It's tough to see. So C is over here. Best way to remember these things is alphabetical. Everybody good? So for B, you should have had that the coordinate was -3 because you went to the left, and 0 because you didn't go up or down. For C, you should have had 6 and -3. You went 6 to the right and down 3. For D, you should have had 0 because you didn't go left or right, and -3. And for O, 0, 0. Yeah, that's it's right on the origin. We call that point the origin, right at center. Okay, it says write the coordinates of the points in the second quadrant. Which quadrant is the second one? Top left corner. What's the one point in that quadrant? E. Write the coordinate for it. E. Second coordinate. That's a 5. It's just telling you that you're 5 up. Yeah, dude.
So would B be in the second quadrant or in the first?
Good question. What quadrant is B in? Yeah. Kind of both. So you would just call it on the x-axis. So your value for E should have been -2, 3. You went 2 left, 3 up. Write the coordinates of the point in quadrant 3. So what all's in quadrant 3? It's an F. Yeah, it's an F. You can call it a P if you want. I mean, you're probably not going to fail on it, but it's an F. What's the coordinate of it? -4, -3. Perfect. Complete the following table using positives or negatives. So everything that's in quadrant 1, are the x values positive or negative? Positive. So the first blank would be positive. For y, what would that blank be? Are the y values positive or negative in quadrant 1? Positive. Yeah, beautiful. So that means for quadrant 2, your x values would be negative. Your y's would be still positive. Switch to quadrant 3, and you have negative, and switch to quadrant 4, and you have positive and a negative. So if you were to go back a slide like this, and you were to write out if it was positive or negative. So for every time you have something up here, your coordinate should be a positive number and a positive number. This can help you remember if you're putting in the quadrants properly. This one would be negative, positive, and this one would be negative, negative, and this one would be positive, negative. It's simple, right? You have a question, or just switch it? Okay, cool. All right, and this is what I'm talking about when I say it could be fun. So, yeah. Don't get too excited. What you have, they've taken toothpicks and they're making triangles out of them. Draw the next 2 patterns. Draw it out. Draw it out on your paper. Actually do it. No. If you've honestly ever watched, like, if you draw that, I'll use the drawing that I'll talk. If you've ever watched the science class, they reorder the entire room however they want at the beginning of every class. They sit with their friends. They put the desk back at the end of class like this for you guys. It takes, yeah, for you guys it would be a waste of 20 minutes. It takes them about 1. But yeah, and we do the whole class basically like just walking through and having massive discussions about whatever the heck we're just talking about. No, that's what Science 9 does. Like honestly, that's the whole class. It's before you guys every day.
I thought
Pardon?
what class do you want to film? I remember filming my computer.
That's science. Yeah. And it's a lot of fun. It's chaotic, but it's always on top. Like they're getting good grades. That's a class that, like, because it's always on topic, and we can do things that are fun, but then they stay on topic and go back on topic. Yeah, Josh.
You know the first class, like it's we do before lunch because we have more energy than that.
Yeah, I don't think that's what it is. Okay. So, did you all draw your diagrams? I don't think that's what it is. So you should have 4 triangles as your 4th picture, 5 triangles as your 5th picture. Yeah. Okay. Part B. Along the top, they have the number of triangles. Along the bottom, they have the number of toothpicks used. What would be the next number? So to get 2 triangles, how many toothpicks did we use? 5. For 3 triangles, 7, 9. It's just going up by 2, right? Okay. So, part C says, on the graph, represent that table of values that we just made. What it's telling you is to plot the coordinates. So, the bottom, your x value, is your t. It's your number of toothpicks. So go ahead and graph it out. Your y values are your p. Sorry, your t is your number of triangles, your p is your number of toothpicks. After. Nope, after Liam. You go. So, if you did this properly, the first triangle took three toothpicks. So you'd have a dot here. Second one took 5. Third one took 7. And so on. Would you connect those with a line?
Yes.
What? Good question. So we got some yeses, we got some no's. Why no? Because what? That's a good lead into it, Braden. Right, so if you had 1.5 triangles, which you don't ever do half triangles, we only had whole triangles. There's no number of toothpicks you would use. Okay, Braden? So that's what he's saying, there's no data in between. Which is kind of where Michael came from when he said over time. So the idea is that it's not fluid, it's not continuous. These are discrete pieces of data. So if they broke it down a little further, they could do thirds, right? They could do, if you added 1 toothpick, then you'd have a third of a triangle. Then that would be different. But our data right here is discrete data. Discrete data, meaning it's just plotted points. It's not continuous. So part D, we just said, explain why it doesn't make sense to connect the points in a straight line. Part E, describe the relationship between the number of toothpicks and the number of triangles. We already did that. So an answer to that would be, for every 2 toothpicks added, we add a triangle. Make sense? It's easy. F, write an equation that can be used to determine if the number of toothpicks, we know the number of triangles. This is when it gets a little bit hard, guys. You're going to have to take data. You're going to have to take data and write out a mathematical equation. So what would the equation be for this? Using P and T. Wow. 2T plus 1 equals P. Y'all like that? Yeah. So, if there was 1 toothpick, you would put 1 in there. 1 times 2 plus that leaves 3. Or sorry, if there's 1 triangle, right? 1 triangle would equal 3 toothpicks. That makes sense. 2 triangles would make sense because it would be 4 plus 1 is 5. 5 gave us 2 triangles. That makes sense. What if there was 0 triangles here? 0 times 2 would be 0. Plus 1 means we have 1 toothpick. 0 triangles equals 1 toothpick?
Pretty much. 1 toothpick still is
Right.
It would work like that.
So that one doesn't quite work out, does it? Works for everything but. It does work for everything but. What about negative 1t? So if we had negative 1 triangles, would that even make sense?
Yeah.
Wouldn't make sense at all. You don't have negative triangles. So what you could do is you could do exactly what Josh had talked about earlier in the class. You could use your domain and your range. So what does your domain have to be for this equation to work, Pat? What would it have to be? What's the lowest value of t that would make sense? 1. Is less than or equal to? T. And then is there a maximum number of t that you could have?
Drink as much tea as I want.
As much t as I want. Yeah. You'd have 1 is less than or equal to t. And then Josh mentioned something else. Yeah. You said something about you have to say what it's a part of.
Cool. You have to say it in a real number.
You would go p. So this is the second part of these types of equations. You have to say what types of numbers they can be. T is an element. That's what that funky little e looks like. Means is an element of. And then you have to choose the number system. Remember from the first unit, those number systems? So what would our number system be for t? Element of real would work, but we can do better than just real. If you can't have a decimal. Natural. Yeah, I like natural. Okay. T is an element of the naturals. I like that one.
I like how to know what it wants.
The equation's good if you put that on the side. So, the equation is good, but that's part of the equation. You have to have that on the side of it. Because the equation isn't good if you don't specify. Does that make sense? You'll always have to specify. And when it's just a broad one where x could be anything, you just go t is an element of the reals, meaning t can be any number that we know. And that's what you're typically going to see. You're typically going to see t is an element of the reals. Like that.
So you have to watch is to your weakness, but the t.
Where t is an element of the reals, you just put t as an element of reals, unless it's asking for a domain or range. This one, you wouldn't even have to put it because natural numbers doesn't include 0. So you're right. You just leave it as t as an element of the naturals. Final question. This is talking about continuous and discrete. You get from the office. No, Bell's going to go. We already talked about this, discrete and continuous. Continuous means it's always connected and always going. That's when you draw your line. And discrete is direct points. So time taken to complete a 100-meter sprint, would that be continuous or discrete? Continuous, because it could be anywhere from 0 all the way up to any range, right? It's not, you could only finish it in 9 seconds. You could finish it in 9.693 seconds. Right? Shoe size. Discrete or continuous. If you're buying shoes, it's discrete. That's different. It's just asking about your shoe size. It's either a 10, a 10 and a half, an 11. Yeah. But it's still discrete.
Yeah, like my Jordans, you know.
C, the number of students who pass 10C, is that discrete or continuous? It's discrete. D, the height of students, is that discrete or continuous? It's continuous because if you measure it specifically, it's a whole range, right?